Yeah, we have this webinar about this big question: is there enough biomass to defossilize the chemicals and derived materials sector by 2050? The project was financed by Berg and RCI. We have in a few minutes also a slide on Berg and RCI, and then also Marco Rupp from Berg. He is present today. We also give a short introduction. As you see in the timeline, this webinar was already done 3rd and 18th February this year, but this was only 1 hour. I've decided to do it today 2 hours, that we have enough time to discuss also details and assumptions. And today from the NOVA team, Olaf, Berg, and I are present. Olaf is in the background with some additional very detailed presentations. So if you have some very specific question, we can also go to Olaf's presentation, and Marco. So we three are here today. And I'll take a look what are the next slides. Yeah. On next 2 slides, I would first show you which publications are available. And then we have a short introduction from Marco and me. And then we start, when we have a deep dive in the topic. I will just organize here some details. We are now 64 people. And I think the easiest way to get in contact to us is with question and answers. So please don't use mainly the chat. The chat you can use if something is not working, but for content question, it would be the easiest way to use question and answers, because then I can pick up the questions, or Olaf, for example, can also give directly some answers to your questions. So this study was done over a long time, I think 1.5 years. We worked on this report, and there are different publications I would like to show you first. If you want, after this webinar, you want to go to do more details, or you're looking for the pictures. Here you see in the middle from February is the main report. Is there enough biomass to defossilize the chemicals and derived materials sector by 2050? A joint Berg and RCI scientific background report. My presentation today is mainly focused on this publication. On the right-hand side, you see some additional reports on fuel markets, aviation and shipping, and also reports on the future of chemical industry. I will quote from these 2 reports, but you can also download them from the link you see below, renewable-carbon.eu/publications. And on the left-hand side, you see almost the same presentation like today. I have changed a few slides, but in 95% it's the same presentation. So if you like the presentation, you can later also go to the shop here, renewable-carbon.eu publications, and download this presentation from today. So these are the 4 main presentations in this context. And in addition, so we added last week some additional background information. The first time, you can also download them free of charge. The first is a deep dive in the forestry sector. So much more details about forestry. And Olaf is here today. So if you have specific question on forestry, we can also take a look here today. The other report is a deep dive into agriculture sector. There you see all the details, calculations behind the presentation from today. Then a very interesting background report measuring the use of biogenic feedstocks in global and EU chemical industry in 2023. This show where our data coming from. So from literature, from other associations, from companies. So this is a detailed assessment on the demand of the chemical industry today. And this is a living document. So if you have some feedback on the numbers, we are very happy to integrate them in the next update. And last not least, on the right-hand side, we also published now a summary in a magazine where you can see on 3 pages the main results as a quick overview on the whole work. So this is all available under the same email web address down. And now I switch to the two associations which have financed this big work here, the big modeling work. And I first give the word to Marco Rupp from Bio-based Industries Consortium. He wants to say some introductional words to this project. Please, Marco.
Thank you very much, Michael, and welcome everybody joining our third webinar on this important topic. Well, defossilization, this is obviously at the heart of what we do in the Bio-based Industries Consortium with our 300 plus industry members and over 200 academia members trying to make the business case of tomorrow if it comes to defossilization. And interestingly, the other day I have a little pile of studies which deal with biomass availability, and there are quite a few of them. And I thought, why there are so many studies, and where does our big RCI study play into there? I think my first takeaway from this pile of things was that biomass availability to defossilize is still an elephant in the room if we talk about how to do that in the next years. If it comes to the political discussion, this will not only be discussion about facts through these studies, but also through trust. So there's certainly no lack of studies. But what I believe the RCI and big study makes it really different is that it, first of all, provides the outlook to 2050. It does that through a really solid database, really good assumptions, and also a good modeling. And that's why it nearly took us a year to complete the study. So whilst you can certainly discuss those assumptions and those data and the results, and that's why we're also here today. I mean, please constructively criticize. You cannot deny that I think the results are really good. And that's also something being acknowledged in the meantime. If you talk also to the policymakers, if you talk to other industry members, if you talk to the GRC, which promoted our study, I think you can also details, but you cannot deny that this study builds trust because it shows that both RCI and BIC are very serious in this defossilization, and our contribution we make is also with this really solid study. So I leave the details on the discussion now to Michael and Olaf and all the participants. And I really look forward to having another workshop today because it always makes it better in what we do here. Thanks.
Yeah, many thanks, Marco. That was very good starting point here. There are many reports out with very different results and answers, but only a very few of them really have models behind. And you learned today a little bit about the models. And this modeling is a key because this modeling is also including decision-making of farmers from the last 40 years. So we know very well from the models what are farmers growing under which conditions. And this is a very complex set of background data. And many other reports here have not done this depth in assessment. On the other hand, of course, I show today also in detail our assumptions. If you change the assumptions, we can run another modeling. And then, of course, we have also other results, but we try to make this as solid as possible, as Marco said. And so far, the response from the experts and the policymakers was very positive to our study. And I'm happy to share today as most details as possible. Yeah, Olaf is also here. You see Olaf, and Olaf is on the one hand side, he will also look to the questions. So Olaf, please, if you see an important question, interrupt me anytime. And Olaf will also have a background, other presentations for even more detailed data if you have very specific questions. So Olaf is a little bit moderating in the background this procedure today. Okay. Yeah, we have here BIC, and I think most of you know BIC, Bio-based Industries Consortium, is described here shortly, and Renewable Carbon Initiative, both together finance this report. This was also a little bit nice story, Marco, from the history, because both groups wanted to do almost the same. Then we have invited both groups to say, let's put budget together. Then we are able to make a bigger modeling to go more in details. I think that was a very good decision. Okay. Yeah, a short view on very short view on RCI. RCI has meanwhile about 80 members, and it's an interest group to organize this smooth transition from fossil to renewable carbon with brands, startups, partners, research institutes, suppliers, mainly from the chemical and agriculture and wood sector, and also SMEs. And NOVA, who did the study, NOVA experts, together with the modelers, for modeling, you need specific experts, so we couldn't use our own team for that. NOVA is working in the field technology and markets, sustainability, communication, economy, and policy. And here, mainly the economy and policy group, where Olaf is part of, was here working for this project, and also some experts for the technology and market department. So the basic question of the whole project was, is there enough biomass to defossilize the chemicals and derived materials sector by 2050? And to answer this question, of course, we need a lot of background information. And first, I want to show who was working together here next to NOVA. We have, for the agriculture modeling part, we have the company Eurocare with the CAPRI model. We have later one slide of the CAPRI model. And if you want to learn more, Olaf has also more information in the background. This is a model which is used, for example, for the European Commission, DG Agri, and there are worldwide very few scientists which can really work with this model. It's also a community, so they're meeting regularly online and putting new data in the system, discussing updates of the internal structure. So there's a living community responsible for this CAPRI model, and Eurocare in Bonn, Germany is one of their locations. For the forest modeling, we was happy to find Thünen Institute from Hamburg. We tried a lot of different institutes. There were only very few, but all was busy for the next 5 years. We was very happy that Thünen Institute, one of the leading forest modeling institutes in the world, was able to join this project. The period was from December 23 till February 25. We had an advisory committee from big members and RCI members. This was very important to guide the process and also to helping us to get data on the demand from the chemical industry. So this document, I'll show in a minute, was worked together with all members of the advisory committee. There's already one question here. Conversion of biomass can also release biogenic CO2. Yeah, this is a very specific question, but of course, we're also working a lot on CCU, on the utilization of CO2, also biogenic CO2. This is not part of this model here, but to give you one number, the pulp and paper industry in Europe has more than 1 million tons of biogenic CO2 emissions. They're starting to utilize it, and we think it is a very good idea to capture and use this CO2. But what we can deliver from this CO2 is shown on 3 slides today, but it's not part of the modeling. Yeah, the key question here, again, if you look what is the situation today, so the meat, so we have here a target of 20%, that the biomass supply 20% of the carbon demand of the chemical industry in derived materials, especially the plastic sector, in 2050. You will see in a minute why 20%, where the number is coming from. But first, it's important to know what situation today. And today in Europe, we're covering 5.5% of the carbon demand of the chemical industry by biomass, and globally 10%. These are the starting points. And why Europe is behind the global situation? The main reason is that we have so many decades cheap Russian natural gas and oil, that it was so easy to stay on cheap oil and gas, where globally there are countries which have not so nice access to crude oil, so that they are more interested to use their domestic biomass. So this is the starting point. And if you want to go to 20% in Europe, it means we assume almost stable demand for the next decades. that it have to times 4. So we need 4 times more biomass in Europe for chemical industry. Globally, it's also times 4. It seems to be times 2, but at the same time, the global demand is also doubling. And so we have the situation that in the global case and the European case, we need 4 times more biomass for the sector compared to today to reach this 20%. And there we have to check in this project, is this possible? Is this realistic? But the first step is, the first milestone was, what if I go here also some in-depth information. We have enough time today. So when we talk about the energy sector, heat, but also, of course, traffic and electricity, then there are good concepts with solar, wind, and hydro to decarbonize the energy sector, mainly through electricity and hydrogen. But for the chemical and derived material sector, this is another situation because they are depending on carbon. We have in these products embedded carbon. And so here we can't speak about decarbonization. We need to defossilize the sector. So we have to replace the fossil carbon in the molecules by carbon from other sources. Today, 90 to 95% of the embedded carbon comes from fossil carbon, oil, natural gas, and coal. And to achieve sustainability in the long run, and for example, till 2050, we have to replace this carbon by biomass, CO2, and recycling. And the key question is this possible, and what share can biomass play here? This was the first milestone of the study, and there we have now a full background paper published. What is the demand today? And you see here is calculated in, on the one hand side, it's in dry biomass. So the unit is here, 1 million tons dry biomass. But we have also translated this to carbon, you see below, and almost a little bit more than half of the biomass is carbon. The other components are oxygen and hydrogen and others, of course, nitrogen, sulfur, and so on. But here we're looking mainly to the carbon share. You see, today the world is using mainly for chemicals and plastics and other and detergents and body care products and all this derived materials, mainly starch. Starch has the biggest share. The second biggest is sugar, then vegetable oils, natural rubber, chemical pulp. And then in small shares, we have also animal fats, glycerol as byproduct for biodiesel production, used cooking oil, and palmy fatty acid distillate. In Europe, it's not so different. So this was the first big exercise because this number you can't find in any statistics. And that's the reason why we have an ongoing research to updating this data here. And when we look into the future, it's interesting how the future could look like. And we have here evaluated different reports. This is also to see the study on the left-hand side, to see what in the last 5 years was most reports on world, global level, European level, have a forecast or scenarios for the future of the chemical industry. And here you see 16 scenarios from 9 reports. And interestingly, they all see biomass, CCU, and recycling, and some still fossil, in this case here in average, as the future of the chemical industry. So biomass is here in an average with 22% share responsible for the carbon supply of the chemical industry. We see even more for CCU and recycling. And the fossil part is partly balanced by CCS as far as this is possible. So this was this result here. You see already 22%. So this is here what I see. Then we look into the other scenarios for the plastic market, net zero plastic in the future. Here, biomass again is about 20%, 21 here. CCU is smaller, and recycling has the biggest share because plastics are easier to recycle than detergents or body care products or lubricants. They are not easy to capture and recycle. So that's really in line with realistic assumptions that for the plastic sector, recycling is the most important part. But in both cases, we see about 20% biomass. And then there is a famous scenario Nova developed and later together with RCI made it more detailed. This scenario where we are fading out fossil carbon till 2050 completely. So in 2050 we have no fossil carbon, no virgin fossil carbon in the system anymore. You see also that the demand on world level is doubling from today to 2050. The growth rate is 2.5, the compounded annual growth rate. This is lower than in the past. In the past, this was more 3.5, which is 3 and 4. So we're already taking into account that the growth in the chemical sector will lower than before. For Europe, we have 0. We have for Europe almost the same demand as today. But we have to keep in mind that countries like India, they have at the moment growth rates in the chemical industry 15% per year. So we have a lot of developing countries with chemical industry where we will have a lot of additional production from also for plastic for packaging, because one of the main reasons for food losses in the value chain is not suitable packaging. So we will see here a lot of more production of packaging in the future, and this is so we think from 3.5 it will go down to 2.5, but that means from 2020 to 2050 a double demand. And in our scenario here, we say biomass is 20%. You saw it's very well in line with the evaluation of the other reports, about 16 other reports or scenarios. You'll see the recycling share is here 55%, 5% still from fossil, the others already from bio-based, CO2-based recyclates. And the gap is then filled with 25% CO2-based. And in this report here, we try to find out whether the biosector is able to provide this 20%. And so if you see later some results, it's always related to this 20%. So there is no way that biomass will cover 100% or so. This is not possible and also not necessary, because we have, of course, recycling, and CO2-based is also a real option, which also coming in place in the next decades. So 20% is a nice number, and yeah, is it possible or not? We will see today. If you have any questions here, please interrupt me anytime. The idea of this workshop is that we really have time to discuss in detail assumptions and everything you are interested in. We have to discuss this situation with 20%, of course, also in competition to other sectors, because food and feed are first, for sure, but then we have also some regulations, policy regulation in place for energy and fuels, which are there, so we cannot ignore it. And so we have, especially in Europe, we have a very strong policy on aviation fuels and marine. And you see here the development. The lower part is biodiesel, bioethanol, conventional ones. They will mainly fade out. And then you see the other green part is advanced road fuels. And the others are marine, the blue one, and on the top, the purple, are aviation. And so here comes a huge demand from the fuel sector. And this demand is only allowed to be covered by Annex 9 feedstocks. These are mainly liquid waste streams. It's a long list, but they are mainly second generation and not primary biomass. And that also means that especially if the chemical industry want to get access to the second generation feedstock, there is strong competition to this aviation and marine fuel market. And this we have taken into account. So food, feed, then energy, fuel, and then what is left over for the chemical industry. So some people say, why you make these assumptions? Chemical are more important than fuels, especially for biomass utilization. Yes, I fully agree, but we cannot ignore existing regulations. And this year, what you see here is decided by Commission, Parliament, and Member States. So that is the reason why we took this food, feed, and fuels, and then chemicals, because existing regulations. If Brussels will introduce some quotas for the chemical sector or plastic sector, then it's a different situation. Then we have to update this report here, but this is so far has not happened. Yeah, a very quick look to the regulations, because they are so extreme that it's hard to believe, but it's reality. If you look to 2050, 70% from the aviation fuel has to be made from biomass or CO2, and minimum is 35% from CO2. This is really decided, and this is integrated in the model here. Similar things are in maritime, but I focus now on this. Yeah, we have also some sub-scenarios. You can also say use more CCU for aviation fuels and not so much biomass. Then we have a little other scenario. You can also say, like Japanese is doing, use ammonia. So you can run the marine ships, for example, very nicely with methanol from CO2. But you can also run it with ammonia. You need more new engines, but it's possible in principle. Then, of course, also the demand for biomass a little bit lower. And we have summed up this is this slide here. This is the demand for biomass in Europe in different scenarios, just due to the regulation for fuels. And what you see directly, the basic scenario would mean you're coming from 70 million tons to about more than nearly 350. This is times 7. So depending on scenario, you can say between 5 to 7 times more biomass is used for the fuel sector in Europe. And this, of course, is a strong competition to the chemical sector. Any question to that? Otherwise, I will go on. Oh. Yeah, please put, we have, yeah. Okay, Jesus. If we can give you the word. Can you, Olaf, can you give him the word?
Let me try.
You can allow him to speak. Otherwise, write the question in the Q&A. It might be easier with many participants. If you find him in the participant list, you can give, I think you can allow him to speak. Yeah, I have done it. So now you can speak up, Jesus. Okay, here's another question. I will first go. You can talk now. You can now open your mic, Jesus, and talk if you want. Okay.
Yes, now I think.
Yeah, okay.
Okay, sorry. It was a little bit, the word different. Yes, so I wanted to comment, I'm Jesus Alquezar from the European Commission, to comment on this figure about the decrease of the biomass demand for biofuel you mentioned here. I don't know if it's really about biofuels or biomass in general, because most of the biomass we use for energy is not biofuels, so bioliquids, is solid biomass. It's around 75%, if I remember well. So not about this figure, the next one, because you calculate that there will be a decrease. But according to the models of the Commission in the Climate Target Plan 2040, there will be indeed an increase, which in my view is challenging compared with literature review that is indeed saying that already our use of biomass is not sustainable, and we see that the carbon sinks are going down, that there is a loss of biodiversity in Europe. So I would like to see in the reality what you are modeling.
Yeah, you will see in a minute.
I'm not sure this is in line with the modeling of the European Commission. I'm sorry.
No, but we have checked this data here with DG Move, and they was fine with that. And you see the decrease is only in the traditional capped biodiesel, bioethanol. And of course, in total, we have a big increase, for sure. But the
Okay,
increase coming
I
from...
think this clarification is very important because biofuels are around, I think it's 25% of the biomass used for energy. So
And what you see here, we have a huge...
it's a small part.
We have a big increase in the biomass used for sustainable aviation fuel, for marine, and for advanced biofuels in road, but not the traditional ones. And you see, we have here calculated the demand is really going much higher in the different scenarios. So it's ×7 higher in basic scenario compared to today due to the demand from marine and aviation fuels. So the decrease is only for the traditional...
But my point is that you are not assessing the heating and cooling, which is most of the biomass. Maybe it's coming later in your presentation.
Now, this is so far not a main, not for main interest from the chemical sector. But right, we have here only chemical sector and fuel sector. The system on biogas or incineration from solid biomass is not covered here because it can't not directly used for the chemical.
Okay.
But
okay, thank you very much. Thank you.
Yeah, now we are in line. Great.
Yeah, okay, clear.
And L, the question of L was here. I missed what is mean with strong ammonia, strong CCU. That means that bigger shares, we're looking here, for example, if you are allowed, so it is a minimum 35% aviation fuel made from CCU, minimum, but we can also do 60%, 70% of the fuels by CO2. And in these assumptions here, the share of production from aviation fuels and marine from CCU is assumed here much higher than from biomass. And the ammonium case then is mainly for marine, not for the aviation sector. Here we see that you can also replace the biomass by capturing for nitrogen and make ammonia from it and run the ships by ammonia. Then also the biomass demand is lower. So the basic means 35-35 biomass and CCU, and the other scenarios have more CCU or more ammonia and less biomass. Okay, so this was the competition. So scaling up, when we want to go from this share today, 5.5% to this 20% share, we have to scale up the feedstocks. And this can be done in different ways. This was long discussions in this advisory group. And we're looking here mainly to the case 20% wood and waste. So from the 20%, 20% is made from biorefineries using wood and waste. And you see here that still the share of starch and sugar is here assumed to be very high, also mainly because of the competition to the other sectors. But we have also put this in a graphic so that easier to see. Here's a European case. Left-hand side, you see the demand on million tons dry matter biomass today, 11.5. It's mainly coming from primary agro biomass. This is mainly starch crops, sugar crops, and plant oil. You see some byproducts and some wood products. We see later where the wood is used for. And on the right-hand side, we see the picture of the future, where we have 4 times more biomass in the chemical sector than today. There still are the starch and sugar crops are still a very important part of it, nearly 50%. But we see, of course, now a bigger share of straw, bio-waste, and wood through biorefineries, and also, of course, the byproduct utilization. So this situation and we see this is from the demand side. We have, of course, to calculate later whether supply can cover this demand. How will climate change? Yeah, this, of course, is also a question I want to discuss a little bit later. What is the impact of climate change? When we look into the assumptions later, then, of course, we have also to discuss climate change. So this is from the demand side on European level, and we can, and now we have also CAPRI models comes now in. What is the CAPRI model doing? The CAPRI model is an equilibrium model. So that means that demand and supply are always the same. Yeah. So if you see it later, it's not by random. This is finally it means there is over the years no production of biomass without demand. If there is no demand, there will not be biomass production. So over a very short period, we have always this balanced situation because demand and supply. CAPRI future projections are based on historical trends. So that means there are 40 years decision-making of farmers in the system. And you know at which price level sugar beet farmer will switch to another crop and so on. So this is all in the model from real life data. Then we have the data from OECD Agriculture Outlook. This is one of the main sources of the data. And there is also a consolidated trend projection from the CAPRI database. So CAPRI has their own database, but it's mainly working with OECD FAO with a few corrections and some additional things. In the model, we have 50 commodities. So all relevant agriculture crops are here. The exploratory scenarios are based on plausible range of assumptions, I'll show you later, to assess impacts with a focus on the sustainable availability of biomass. Yeah, and then I said already, food and feed has priority, of course. So the assumption is that there is enough food and feed for everybody in the world in 2050. In addition, the existing European global regulatory framework with quotas-driven demand for biofuels. Also, there's a need for a level playing field between both. This taking into account this framework, and we have to take it into account. So what scenarios we have developed here? You see 6 scenarios. First is scenario business as usual, that's just continuing the trends we have today. Then we have green high-tech scenarios with the assumption of additional yield by in Europe 5%, globally 10%, Europe 10%, globally 20%, or globally or plus 15 in Europe and plus 30. So 3 green high-tech scenarios. And we have 2 scenarios, low resource depletion, where there's more organic farming and more set-aside land and so on. We see later some details here. And so we have calculated under these 6 scenarios, which of the scenarios is able to supply this additional demand from the chemical industry next to the existing demand from food, feed, and fuels. And to the question of the solid biomass for the heating sector mainly, or electricity sector, we have in the forest calculation, there's one slide of this later. The different sectors are in modeling very separated, but we have a last slide where we have also data on this fuel wood, as it's called. So all wood was used for heating electricity. There we see that they have some additional space for optimization. One important comment is here to understand the model assumptions. This model has internal economic feedback processes. And here we just want to give you this example here. I have to look whether there's something here. No, that's fine. For example, in the biomass production green high-tech scenario, when we take into account this extreme scenario plus 30%, there's a lot additional biomass production, and then the model lowers this value directly to 17.6. This is due to economic feedback. That would mean if you grow, for example, 30% more sugar cane, then the price will go down. There's too much production. There's not enough demand there. The price goes down. Next year, many farmers decide not to grow sugarcane anymore. And due to those feedback processes over a few years, the real additional production is only 17.6 and not 30. And this is true for all these green high-tech scenarios, but also for the the low resource depletion scenarios, where if you have less yield, then the price of the biomass goes up, and then there is grown more. And so the biomass production minus is also not 10, but only 4.4. This is just an example how this modeling works. And then Marco said at the beginning, there are so many reports outside. Many reports making this very simple with an Excel sheet, without all this interaction internally. And this is CAPRI is here very one of the best models in the world. But the disadvantage is, of course, if you ask us, yeah, why it's 6.1, then the modeler have to look 5 hours as a model or 2 days as a model to understand how the feedback is working and so on. That means what the model is doing internally is not very transparent, of course. And we had, during this 1.5 years, we had a lot of questions the modeler. He could answer all questions finally, but it took a lot of time to answer the question. And this is the disadvantage if you have a very complex model with many feedback loops, how you can answer quickly some questions. Okay, now we come here to the assumptions page. I think this is an interesting page. I take the time today to go through the different levels here. These are the assumptions for the global situation. So here the world population is going up to 9.6 billions. We have new studies now. We say it will not reach so high levels. It stays a little bit lower. This has big impact on the model, of course, but this was the assumptions we could find when we're doing the job in early 24. This was the most quoted assumptions here. Then we have nutrition, average dietary energy availability. This is, of course, the level that nobody is hungry in the world. The differences here for the different scenarios coming from a little bit different food mix. There was eating, so in the low resource depletion, there's less meat, for example. This has a certain impact on the total numbers, but they're all around 2,500. The harvest agriculture area is increasing. This is directly connected to the cropping index. So we have, of course, also different culture areas due to climate change, due to deforestation, and many impacts, of course. But one parameter is the cropping index. The cropping index means how many harvesting you have per year on 1 hectare. And there was just last week in discussion with some Asian experts, and they say in Malaysia or Thailand or so, we have areas we can harvest 3 times a year. And today on world level, we have 0.96. So we have not even 1 harvest on 1 hectare in average. And the assumption of FAO is that this number will increase to 1.05 till 2050. With modern high-tech agriculture, it could also go up to 1.1 or 1.2. But this has, of course, a strong impact on the harvesters area because this is the area times the cropping index. Then we have land set aside for biodiversity protection. So we have this business as usual, where only this was really well known and decided is taken into account. And in the other scenario, we have additional land set aside for biodiversity in the LRD +8, in the high-tech scenario +4. Why high-tech can deliver it is also because it's very resource efficient, higher yields, and so they can even make a huge biomass production with less land. So here also some additional land can go to biodiversity protection. Deforestation, it will all stop in 2030 in high-tech and low resource depletion. This is only the minus here 2020 because then it stopped. Business as usual, it will continue a little bit longer. Whether this will happen or not, we see some countries now we are allowing a lot of deforestation again. We have in Brazil the highest numbers since 20 years. So if this is not happening, of course, this has strong impact on agriculture, more or less. But these are the assumptions we found in literature as the most probably. Conversion of wasteland, marginal land, thawing, permafrost, agricultural land. A very important point, directly connected to the question on climate change. We try to find out a report who was able to give us a number of the net change in agricultural land due to climate change. And this is on solid base not possible. So that means on the one hand side, we are losing, of course, arable land in the south. it's getting too hot, too dry. On the other hand, we're getting additional land in the north, in Siberia, Canada, Norway, Sweden, permafrost areas, but the net impact is not easy to cover. That means we have here not included those scenarios because they are not on solid ground. What we did here is that some of this wasteland, marginland, thawing permafrost can be converted to agricultural land. And we have here the highest assumptions in the high-tech scenario because there are a lot of technologies will be available to do so. Then land take for settlement and transport infrastructure. You see the business as usual, taking a lot from cities and streets away from agricultural land. But we have here the assumption that the lower research depletion, and in the high-tech scenarios, this will really be a lot lower than business as usual, that we're protecting important good land not being taken away for settlement and transport. The area under agriculture, organic farming, there are in business usual and high-tech 10%, and in the green low depletion 30%. Then increasing crop yields through technology. Here you see in the high-tech it's the biggest number, but even in organic farming there is a lot of progress in yields. So we have here 0.5, 0.7, and 1.1. So these are the main assumptions behind. Of course, there are more assumptions, but these are the most important ones. When we look into Europe, I will not repeat the whole exercise here. They are similar, but of course, in conversion land or deforestation, we have not so much space compared to the global situation.
Michael, maybe from my side, also in addition to the scenarios, how they worked in the model. So if you maybe go back to the global assumptions. So for instance, they were also in close exchange with the modelers. So we had a set, if you can see here, the parameters that we wanted to include in the model, but we also had to adapt it accordingly to the model. So the CAPRI model gave us, for instance, the development of the agricultural areas in these different scenarios, and then we had to look what kind of shares could be for instance, the deforestation part. How much could be the share which is the land take for settlements and transport infrastructure. So also here we were good in direct exchange with the CAPRI model, and also dependent what the model was giving us. So we didn't came up with these numbers. So this was actually also like a result coming from the model itself that we had to interpret and analyze and evaluate to come up with these parameter list.
I think that's also a good hint, Olaf. Thank you. If you think about making own projects on modeling, we was in the beginning naive, and we thought we can give the modeler one set of parameters after weeks of discussion upon the parameter, and then they make one run, and then we are final. In reality, it looks very different. You have to run the model 10 times, 15 times, look into the results, try to understand the results, see, oh, that was not what we meant. So it's really a learning with the modeler. You adapt your assumptions, to run again, you see what it means, and so on. And this is really, so if you plan such a project, be aware of the time budget you need to perform it, because it's not one assumption set, one modeling results ready. It's a continuous loop process.
Yeah.
Yeah.
And then one more question, I think also on climate change. So no parameter around impact on average temperature increase or variation of rains effects on yields.
Yeah, but on the other hand, there are studies what we got in additional yields in the north. So the problem are the net effects. Yeah, and when we put only in the model what's happening with the lower yields in the south, and also it's not really to predict how the rainfall will develop over the next decades. It can happen that some areas which are too dry have more rain in the future, other areas have less. But you can read a lot of reports, and they have a lot of assumptions and scenarios, but nobody is really able to say finally this will happen, and this is a net impact of climate change. This is really a pity, but then we decided not to include it because otherwise we are only depending on the latest assumptions on climate change, and this is also not a fair model. And we see, of course, that Russia is very interested to get more agricultural area in the north. And the question is this realistic? What technology we need for additional yields? But yeah, again, so we have not covered climate change impact in this report here. You can say as a weak point, and we are happy to perform it next time in 2 years again. But I would want to wait till someone is able to really say net impacts. And this is also on FAO and OECD. They're discussing the same questions here. And they also have decided they cannot say a net impact so far. And if someone has here, we know these studies. And we keep an eye on all the studies, of course, but they are not yet included from a good reason. But we know if it will happen that US will have such a decrease in corn yields, which is here in another study, it would be very dramatic, of course. But who can predict the rainfall in 2050 in this area in the US? Almost nobody. So we have to be very careful, and what we're doing with climate change is taking a big risk for agriculture, no doubt, but the model was not able to really break down the risk to real numbers. Okay, what is also important here, sustainability. I've addressed this here also in addition to what we was able to include here. Climate change was not included, the impacts, but what else was able to include in the model? The first is how to define sustainability. In the CAPRI model, it's understood as sustainable development as the original definition from Brundtland in 1987. Sustainable development means a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And that means when we're calculating here data for 2050, in principle, we can get the same yields also at 2060, 2070. So we have not a model here which is really taking everything away from the soil, that we're able to have high yields in 2050 and after nothing. The model is try to understand what will happen to have a long time biomass production on the size and the volume we have here in the scenarios. The next thing is the modeling is not able to account for whether biomass produced in a certified sustainable way, but it does guarantee that it will be available in the long term. And of course, we can also develop till 2050 certification systems as all biomass, food, feed, fuels, and chemicals will be only produced in a certified sustainable way. That is possible. The systems are there. We can roll it out. But this is not included in the model, and it's also not have a real impact on the yields finally. But I would love that every biomass is certified, or then if everything is certified, we don't need certification anymore, that we have really strict rules how to perform biomass production. And the high-tech agriculture systems have also a big eye on sustainability issues. So I think here it's also possible to integrate a lot of, for example, soil health is a big job in the high-tech scenarios of the agriculture system. Biodiversity cannot be modeled directly in CAPRI, but there are several assumptions. That strongly support biodiversity conservation. Stop of deforestation, as I mentioned, in all scenarios by 2030, except business as usual. Land set aside for biodiversity protection in all scenarios +4 and +8, except business as usual. Land take for settlement is going down in the scenarios high-tech and low resource depletion. And we have also lower meat consumption compared to Bio. I have no slide on the details. I think we covered, Olaf, you can perhaps add this, that in average, so in the countries with high meat consumption today, we see a decrease in meat consumption, but in countries with a very low meat consumption, we see an increase, and there is something in the middle is for the future, and it's also different for different scenarios. But the impact of this is not so big, finally. I don't know, Olaf, whether you have a slide in your background information where we can give a little bit more light to that. I have in my main presentation only one slide later, but not so much details on that. But of course, the low resource depletion is the lowest meat consumption. Business as usual is the highest, and in high tech we have something in between. But it's very different for the different regions and countries. You can take a look. Whether we have something, then you can just step in later.
Yeah, I will. Yeah.
Okay. But now we come to the main results, and then we have a lot of details now, but these are the main results here. And you see here on the world level, we have also the same on European level then, for the different scenarios. On the left-hand side, you see always two columns here. And the left one is the supply, and the right one is the demand. And you see from today, so we have 20 to 23 as an average. You see the demand, the supply. You see how big the part of cereals is. Cereals is this very huge part of this first one. Then you have protein meal from oil seeds. Then you have vegetables. Then you have sugar. Then you have oil crops, root crops, fruits, and so on. Then you're getting very small. Well, the biggest shares are on world level from cereals, from vegetable oils, plus the protein meal from them, from sugar crops, and from vegetables. These are the biggest contribution on world level. And on the demand side, you see food, feed, the biggest one by far, biofuels, chemicals, very small, and other industries. Other industries is from FAO, a combination of a lot of crazy sectors. To give one example, if you take potatoes and makes chips from it to eat later, then the process oil to make these chips are not food or feed, but other industries. And so other industries is a collection of a lot of different sectors, not so important for us today. And then you see the future scenarios. The first information is you need the high-tech +10 scenario to cover this 20%. So the violet part for the chemical industry, from the top, the second, reaches the 20% in the high-tech +10 scenario. In all other scenarios, on the left-hand side, the share is lower. So that means, for example, in low research depletion with lower yields, there's almost nothing left for the chemical industry. And in the business usual, it's less than 10%, so not much more than today. And only in the extreme high-tech scenarios, we're getting much more yields. In the extreme one, +30, it's up to 40%. But this is a very extreme scenario, so I think high-tech +10 is a scenario that is very realistic. We have discussed this results also with a lot of agriculture companies. And the funny situation was, there was first a little bit surprised why our business usual is smaller and so on. And then we found out after 1 hour discussion that in most cases from the agriculture companies, their business usual is our high-tech 10. So that means they have anyway expecting a strong high-tech with precision farming, drones, artificial intelligence, soil health, with mycorrhiza fungi, and so on. So they're expecting this anyway as the normal future. So that means whether you call the scenario high-tech +10 or business usual is up to the scenarios and countries also. But I think this is still a scenario which is very realistic. And so in this scenario, we are able to get this 20%, but not much more. So if you want to cover more from biomass, then you need really more extreme high-tech scenarios.
So Michael, we have a question in the chat, maybe Jesus again. So maybe I will just give you the permission to speak up if you want. Otherwise, I will just read it out what you wrote in the chat.
In fact, it was related to the previous slide, but we can discuss it later. So about the indicators to measure sustainability on one, clearly when we refer to biomass is the carbon sinks. But okay,
Yeah,
we'll
and
discuss it later. I think you can continue with your presentations because we are really more advanced than what I mentioned here. Thank you.
And Jesus, but I can give a quick answer. You are right, but this carbon sink is not integrated in the model, so we couldn't do it in the model, and this might be some important work for the future to calculate the carbon sinks. But the problem is we had also in the forest model we come later also a lot of ideas how to improve the models, but then the answer of the modeler is it takes 10 years and 1 million budget. So we was limited to what the models are able to provide, and they have also a long internal list what they want to model in the future. And I think this is an important point, the carbon sinks, but there is no model so far which really can have a full agriculture modeling combined with a carbon sink modeling. This would be a great thing to have in the future, and so we was not able to do it here. Yeah, it might be possible to make an add-on to the project with additional budget, but a full modeling is not possible at the moment. This is a pity. I fully agree with you. And there's another question. If one had a very low crop, say due to bad weather, which give us, but these are average data. So this +10 is of course a worldwide situation, average over a few years. There might be 1 year better or worse. That can happen, but especially the high-tech agriculture. The reason for that is the most impact of high-tech agriculture is to lower the risks of very low yield or no yield at all, because they are connected to the weather forecast. If there are insects coming, they are detecting the insects very early with drones, so they can really react directly on the insect attacks without spraying the pesticide on the whole field and so on. So if you look to details of high-tech agriculture, there is of course a general yield increase, but the other thing is that they're really looking to lower the risk for failed harvesting. So it can always happen in 1 year. We have in Europe, for example, very high yield in wheat because we have normally since decades and in hundreds of years we have rain in June. If we would have in the future no rain in June, then our harvest here will go down, but perhaps it goes then up in Sweden and Finland. So yeah, but to your question, El, we're talking always about average on regions and years, and there can always be one better year or 1 year with lower yields. That's for sure. And this is also a question of storage systems, of course, also in the future. Yeah, take a look here again. We have on the supply side, but we can go another picture where you can see it more easy. Let's first go to the European situation. It's not so different. The share of cereals is even higher here. And the share of vegetables is relatively low in Europe. We have many imports here. We see also that demand and supply is not in line in Europe. The import gap is always almost the same as in the past. So we have in the future, in the model, not a bigger gap that we have to import biomass than today. On the other hand, if you see the dense population in Europe, and that we have relatively small agriculture areas compared to other regions, and we importing things, produce higher value products from it and export it again. So it would be very surprising if in Europe this was demand supply would be the same. So we'll still import biomass and exports and also products made from this biomass. So this is, I think, also in line with many most realistic scenarios. Here we see also the high-tech +5 in this case is able to provide this 20%. And the shares, you see also the share of other biofuels from primary biomass is going down in Europe. And we can have a better look here. This is globally, this is Europe. Yeah. Here we have just say the high-tech, a deeper look at the high-tech +10 scenario. On the left-hand side, you see the supply, on the right-hand side, demand. And here you see the share of the chemical industry. This is assumed to be higher in 2050 than biofuels from primary biomass. The biofuels then will mainly produced from second generation or waste streams. You see also on the left-hand side the share of the chemical industry for cereals, for sugars, and vegetable oils. It's a relatively small share, and from our model, it can, in this high-tech +10, can be covered very well. In Europe situation, a little bit different. Here, demand is higher than supply, and what is not covered here in the picture left is imported. This is only a supply from European fields. And here you see also again this huge share of cereals. Cereals is mainly wheat and corn, but also, of course, other cereals. And on world level, cereals is also mainly rice. That's also a very important share: rice, corn, and wheat. Okay, in total, also to have these numbers here, we have in total a huge increase in biomass production because of this multi-cropping index, because of additional technologies, better varieties, and so on. Yeah, sugar and root crops. Sugar crops are mainly sugar beet and mostly sugar cane, and all root crops are all other root crops except sugar beet. But in sugar, the main part is also sugar cane. So sugar beet is important in Europe, but not on world level. And cassava, for example, is a root crop we would mention here. It's also a starch source, but not from a cereal.
Yeah, and to add to that, the CAPRI model is also following the agricultural product definition or list that also I think the USCD and the UN databases are using. So yeah, sugar, as Michael said, the term sugar refers then to sugar beet and sugar cane.
And cassava is such a root crop, and this is in Africa used for food, but in Asia is only industrial starch. So it's also very dependent. It is what is used for food or chemical industry in different regions from historical development. Yeah, important is that we have in the business user scenario, we have 31% more biomass available in 2050. And this is mainly coming from cereal, sugars, and vegetable oils. In the green scenario, in the green low resource depletion scenario, it's lower, the increase. It's mainly due to the cropping index and also to some technology progress. And the biggest increase, of course, we have in the high-tech scenario. This is up to 53% in the most extreme scenario. And when you saw before this +30, this is always in comparison to business usual. Business usual has also increased, and then the +30 are in comparison to the business usual. So this data fits very well together. Yeah, and as I said already, the additional yield required is around 10%. So the moderate green high-tech scenario is fully sufficient to meet this 20% in total share of the chemical industry covered by biomass. Stronger high-tech scenarios can even provide enough biomass to exceed the 20%, going up to 40%. But I would not quote it because I would not expect that on a world level, really extreme high-tech scenario as a standard in 2050. This moderate high-tech scenario for sure. On the other hand, when we see how far this drone development is now due to the Russian-Ukrainian war, and we see how artificial intelligence is getting speed, perhaps we are underestimating this, and we can really make precision farming in such an extreme way in 2050 we're not expecting today. But I want to be a little bit careful here and not taking too extreme positions here or assumptions. But it could happen that we also underestimate the situation due to this, in some areas, very quick development of technology. Yeah, this high-tech scenario means especially that we have a more resource-efficient production. And this also allows to set more land set aside used for biodiversity issues. So I think that is also an important information. When I had some meetings with agriculture experts in Brussels, there was this opinion that we should use existing arable land as efficient as possible and leave as much as possible for the nature. That would be the best for biodiversity, because also organic farming has a big impact on biodiversity. So I think this results here goes in this direction, that I think the most sustainable future is in the clever application of high-tech systems to use less land for the production, that there's more for biodiversity issues. Yeah, feedstock of the waste streams. Yeah, we have also this, of course. This is the next part here. Thank you. Then there's also some interesting results on world level. Bio-waste from fields throughout the processing chain, markets and households, food losses is smaller the volume than straw. So we have this worldwide, of course. We have straw, including all kind of straw. So we have included in the modeling all kind of bio-waste streams, bio-waste from the field, on the process chain, market and household, so everything. But it was surprisingly not so big, and it's mainly used for the production of sustainable aviation fuels. Here is a huge demand, especially in Europe, but we see similar decisions now also in Asia, where they also have now targets for aviation fuels, also focusing on non-primary biomass. So that means this sector is strongly absorbed by the demand from especially aviation fuels and some marine. What we saw in the modeling is, if only cereal straw is used, there is not enough to meet the demand for fuels and chemicals in all scenarios. So the cereal straw is not enough. But we saw also, if we are able to utilize the straw from corn and rice in addition, then we have a lot of additional feedstock for fuels and chemicals in all scenarios. I think this was for me one of the most exciting results of this modeling here. By the way, this is also mentioned here, when we talk about straw, we only take 1/3 of the straw from the field, 1/3. For soil health, you could also go up to 50% removal, but we also taking into account that some fields are so far away from logistics that they will not be utilized the straw. So then we have assumed we take 1/3 of the straw, and if we are able to use corn straw and rice straw, then we have really a lot to offer for fuels and chemicals. And we was then in discussion with some producers of agricultural equipment, and they say, okay, it's possible. We need 5 years to develop harvesting system for corn or especially rice. The rice field is not completely dry in harvesting, so we can't use the normal machines for wheat, for example. But this can be done, and we also talked to DG RTD on that. So it might be very useful to develop a harvesting system for all kind of straws, and not only for cereals or mainly wheat straw. This is the point. And I think we have, this is not written here, Olaf, in the best way, because cereal here is meant mainly wheat straw and not all cereals, but when we can, the question of the definition, how you define cereals, but corn and rice have a lot to offer here as additional feedstock. And so it was interesting to see that on a world level is almost not utilized so far. Yeah, and I have just repeated this slide here because we are always talking on this 20% in the chemical industry. We're not talking about 100%. Yeah, that was the main results from the agriculture part. I go back to this most important slide here, this one here. If you have any question or comments, so then I would otherwise use the another 30 minutes for the forest model, because it's also interesting to see that.
Yeah, Michael, there were a question from the chat. I read out this time. Do you think it's realistic to increase yields in such a manner? To my understanding, yields are not increasing, and I assume climate change will push them to the bottom. Yeah, maybe also corresponding to this question, the issue is about use of arable land is that the opposite is happening, with a lot of fertile land being abandoned because it does not give enough revenues. this, for example, the example in the case of Spain leading to rural migration. What you,
Yeah, that is interesting, of course, but this also shows that this shows very well that today we can produce enough biomass for food and feed, especially because this is the biggest demand. And so it's not necessary to use Spain or Australia at the moment. But this can change very quickly. I remember 3 years ago, 2 or 3 years ago, when the Ukrainian war started, there was directly a gap in wheat supply. And what happened then is that Australia starting to grow additional wheat and exporting wheat. Normally, Australia is not a wheat exporter because the soil is not very well, the yields are not so high, and it's economically not feasible to grow wheat there. But as soon as there was a certain shortage on the market in wheat and the wheat prices went up, then the next day we see at many places additional wheat production. And this is also the case of Spain. If the wheat price is high enough, for example, then of course they will also grow their additional wheat. They can also, what is the name, artificial water it, so they can also irrigate, is the right word. So they can also use water in dry areas. So there are many options, and this is also what we learned from the modeler. If you ask the modeler, what is the agriculture area of the world? He asked back, what is the price of biomass? Because you can make a curve, price of biomass and agricultural land. And because low quality land will be utilized the next day if the price is high enough. And finally, we can also use the desert for agricultural land, what is happening by the way, in China. In China, in the desert Gobi, they have this PV agriculture systems where they have the PV panels 2-3 meters high, and below you have agriculture systems, and they're starting there to make from desert agricultural land. And this is only economic feasible with a certain biomass price, but there is not a fixed area for cultivation of crops. It's depending on the price level. And this example with Spain shows this very well. And this example with Ukraine, I took a look to the Australian wheat production, and it was really the case that directly next year they started to grow wheat for export. And so the agriculture system is still very flexible. And so it seems so that we can cover this demand supply situation still very well on the planet. Did you compute 1/3 extraction rate too? Yeah, we have only calculated 1/3 extraction. So we have, when we talked about this harvesting straw from wheat, from corn, from rice, we always calculated only with 1/3. So we could calculate what is the amount of straw on the field, and then we took in the calculation only 1/3, because otherwise it's not fair. We have to leave it on the ground for soil quality. Otherwise, we need a lot of chemicals for the field. So of course, we cannot remove it completely. But if you see what big amounts of straw from rice and corn is on our planet, not utilized today, there's really, I have not the numbers on my head. If you want to see it in detail, Olaf can look to that. We have calculated the amounts. But this really would give a lot of space for additional biomass utilization. Yeah, okay. Forestry questions, please wait a second, because I have 10 slides on forestry, and this is also very exciting, how the forestry sector will develop and interact with the agricultural system. But before, I would like to end the questions or comments on agriculture. Okay. Going to the TiMBA part. TiMBA is also a equilibrium model, and this model is including, and this is also what I can only show at the end. The TiMBA model looks only to industrial roundwood. So we have, when we look into the wood sector, we have industrial roundwood, big part. We have fuel wood, and we have waste streams from the wood, from wood processing, or also from from the forest directly. And the models looking mostly to one of those sectors. So the TiMBA model can calculate the industrial roundwood situation. You see here the 19 products produced from it. For the chemical industry, there is this dissolving pulp going to cellulose fibers. These are chemical processes as part of the chemical industry. And we also can use, of course, for the wood sector, biomass for biorefineries. These are the link to our chemical sector. The other sectors are materials outside the chemical industry view, but they are covered in the model here. And I show at the end of this presentation one picture where you see industrial roundwood, fuel wood, and waste streams. But the model TiMBA is not including the fuel wood sector. And this is also a pity, but we have to work with models which are existing. And I hope, and also the biorefinery integration was done by us. It was not really part of the model, but we could find some tricks to integrate it in a certain way. And then you see here the assumptions, biorefineries. So we have here different shares of the wood going to biorefineries. There was 2 scenarios, where this 10 or 20% scenario. Then we have the cellulose fiber sector. Cellulose fibers can replace cotton or synthetic fibers, of course, also. So we have an assumption how this will develop in the future. Cellulose derivatives are in the chemical sector, are some assumptions. Then we see the sustainable aviation fuel, how that will develop. Deforestation in the green high-tech scenario, no deforestation after 2030. So this is also in line with the assumptions before. Increasing stock per area, that's interesting, whether we can build up forest stock. And this will happen in most scenarios here. Then we have differences in recycling. So in the high-tech scenario, we have the highest recycling share because wood is mainly used in construction, and there it's important how big is the recycling share. And there's the highest in high-tech, the second highest in low resource depletion, and relatively low in the business usual. And then they have also combined, but I will not go here in detail because this is very complex, different GDP and social models. So you see in the low resource depletion model is SSP1. There's another social model than SSP2. And this, for example, leads to the highest demand for wood from all scenarios in SSP1, because the people are very environmental friendly. They are spend more money for materials. They look more to wood-based products than to plastic products. And this is also integrated here in the consumer behavior. And this explains the next curve, where we see how much wood can be harvested per year. This is this picture here. And you see we have the highest wood supply and demand in the high-tech, in the low resource depletion scenario, because of this social model behind. But the difference between the different models are here not so big, much lower than in the agriculture part. And what we also see, that the supply of roundwood in the world is going up. So we will have much more wood available globally in 2050 than today. And this is also in line with a lot of other reports I show in a few slides on comparison to other reports. So this seems to be in the forest modeling world the standard result, that we have in the future additional wood available. Of course, the assumption is also that deforestation will stop. If it's not stopping, then another situation is there. The reason for that, there are some reasons for that. One reason is that we have a more planted forest. So we're going, of course, a share of planted forest going up. There you have much more yield than in the natural forest. Planted forest can also do in a very different way. We see today also, for example, in Finland and Sweden and Norway, that they're starting to, in Sweden, it's stopping a little bit at the moment, but I hope it will only be intermediate situation, that they know better than ever how to make a planted forest more sustainable than in the past. So no monoculture over 100 kilometers. They're also changing the trees very quickly, and there are also different methods to grow it. So of course, the planted forest has to be more sustainable than in the past. We see also Asia especially, and we see China is growing forest. So today China is an importer of wood. In the future, it could become an exporter of wood. And even in Europe, you see in the model here a slight increase in wood supply, around wood supply. Only in Africa, we see a decrease, and this is in competition to fuel wood, as we see later. And in Africa, it would be very helpful to have more solar energy, for example, that they could go away from fuel wood and use the wood more for industrial roundwood applications. So as a first very quick view here. Here's a question from Kalle.
Yeah, I can read them out maybe. So one
Yeah, I can see.
Okay,
It is more challenging to analyze the development of forestry. No, not really. I think in the agriculture system, we have so many different crops, 50 different commodities. We have very different conditions in the different countries. But it's not easy to compare. So in the CAPRI case, we were very closely working with the modeler and looked really deep at the model. In the wood model, we couldn't look very deeply by our own. We got all questions answered by the modeling team from Thun. That was not a problem. It works very well. But we have not so deep insights. So it's not easy for me to compare the complexity or the challenges in the modeling. I'm not sure. Olaf, do you have an answer to that question?
No, I think you answered it, yeah, like how it would do it. There was also a second question by Kalle above that you asked about the environmental Kuznets curve. It's how well it takes into account the change in GDP growth and level of environmental degradation. Do you see any conflicts here?
The problem in the wood model was a little bit that this assumption in the socio-economic modeling was really complex to understand with the impact. So we had a lot of discussion in workshops why this is happening in this, and then there was this parameter, this parameter. If there's really interest, Olaf, you can show some of the background slides, but it's really complicated. And so not easy for me to. I think if you want to have an answer, please write an email to us because we can forward it to the modeler, and the modeler have, of course, answer here. And they were so proud about this modeling here that they also have a publication on it. So this model will be right now or very soon published in a peer-reviewed journal with all details, because for them it was a very exciting job to do this modeling for our case here. So please send an email, or Olaf can take this here and send it to them. Then we need your email, but you will get an answer from the modeling team, but I can't answer it now. Yeah, climate change is not included here. That is the same. Yeah, we have in the forest sector, we have also included some progress, but not as strong as in the agriculture system. So this is high-tech scenario, precision farming, drones, artificial intelligence, and all the things. They are well developed in the agriculture system. There are some leading companies in the world offering this service today. So they're starting rolling it out in first countries. In the wood industry, we was not aware of so detailed developed high-tech scenarios with a strong impact on yields, for example, also on varieties. It could be that we have underestimated the options in the forest sector. That can be. Some was implemented in the model, but here, what I said before, agriculture, there is such a speed in this development, then that the risk is more to underestimate what is possible. But we will see here, but first thing is here, there is no gap in wood supply expected in the next decades. And this is very important because I had a discussion with the German Parliament where there was a consensus, there is no wood anymore, we have a gap and we can't do anything with wood anymore. So the modeling and also some other reports I show in a minute has also the conclusion we will have additional wood supply in the future. So I think this is very important to take a close look to it, because when we have decisions in the policy frameworks, it's very important which future for biomass supply we think is most realistic. Otherwise, we could really make big mistakes in the future discussion. And I will also show you this here the demand side, because this was also for me extremely interesting. In most sectors, we have from today to 2050, something like 200, 300, 400, 600% more demand. Yeah, so we have a huge demand increase. And there is mainly in the traditional sectors. So we need roundwood mainly in the traditional sectors. This is mainly construction, a little bit furniture, construction, and also paper. Paper, you'll see already here is a lot of recycled paper in the demand here already integrated. But the biggest demand is for construction and furniture. And this will grow because we have worldwide a lot of additional homes. We have more space for the people in the future. So here is the demand exploding. We see also here dissolving pulp for cellulose fibers. This was also growing by, I think, 500%, but it's still small compared to construction and furniture and standard paper. On the right-hand side, you see the demand for the biorefineries in our scenarios, in the low research depletion and the high-tech scenario. This is compared to the total demand relatively small. There are different ways to cover this demand. I'll show the next slides. But I was surprised to see what demand coming from the wood sector for the food sector next decades, just also for construction material. And this is really impressive. And if wood would not do the job here, we need more plastics from the chemical industry. Because for construction, there are not so many choices. We have minerals for some applications, we have wood, but wood can be perhaps, if you need so, replaced by some plastics. But from the environmental point of view, that would be a disaster. So it's really important to cover this increasing demand for wood in construction also in the future by sustainable grown wood. And the side streams discussion, I come back to the comparison later. The side streams, here is also a modeling problem, because the modeling is only included forest residues in the form of logging, losses, dumps, burls, wood chips made in the are included in the reported data, but there are only if they have been removed from the forest utilized. That means there is still a potential also in the wood for additional logging residues, which is not covered yet in the model. So here, when we're talking now about this side streams, there could also be higher, but from the model, they're not completely covered. Just because of statistics. What you take out of the forest is registered, you can find it in statistics, but what is left in the forest, there is not good statistics on that. And here the volumes from the side streams from the industrial wood production line is worldwide 210 million tons dry matter. In Europe, 42 to 43 millions. This also calculated by the model. And these are, for example, amounts which are mainly going to the sustainable aviation fuel sector, because they are allowed to use these bio-waste streams. And due to the quotas, they can also pay higher prices than the chemical sector. So it's not easy to get access to these feedstocks. And I promised to show also the full picture. And we also learned this full picture only at the end of the project. I will just look what is coming still. Oh, yeah, okay, that's important. Yeah. And you see, we have still so much fuel wood in the system. In worldwide, fuel wood is almost half. It's for heat and for electricity. And when we was able to replace this fuel wood by especially solar and wind, then we would have a lot additional wood available for construction, for furniture, for chemical industry, for cellulose fibers replacing cotton. Cotton is a big environmental problem, and also cotton cannot grow anymore. It's very limited in the production. Then we would have a wonderful situation with additional wood. But at the moment, this is used in the energy sector. And in Europe, it's a smaller share. is about 1/3. But also here, it's a question, should we use the wood perhaps better in the chemical sector than in the energy sector? But here, it was not included in the full modeling. It was just an additional information to the total volume. The modeling, so the energy sector makes their modeling, the industrial sector makes their modeling, and here's also perhaps a little bit a gap in overarching modeling, including all different sectors. And as I said, we have included the biorefineries, which are not in the modeling. We have included the SAF demand, not in the modeling. So it would be very nice to expand the modeling for the future to cover all the demand for wood. But this was not possible in 1.5 years with the existing budget. Then you need to have much more time and budget to do that. But that would be also one reason for the project was also to see those limitations, of course, that we know in the future when we talking about biomass availability, where are some bottlenecks we have to solve also from the modeling to have a better picture about the future. Here is a comparison to other reports, and in our case here we saw that the coniferous, non-coniferous roundwood supply will be increased by 38%. And the largest is expected in Asia, including China and Russia, but also in Europe we see an increase here. And I have not the slide here, no, sorry. When we have compared this number with several reports, and this is fully in line. So if you see to other reports for the wood sector, their forecast is to have something between 30 and 40, 45% additional supply in industrial roundwood. So I think so the model shows we are here in line with a lot of other in-depth reports. And maybe discuss again how we can cover the demand for the chemical industry. You remember it was 20% from the whole demand, and from this 20 was 20% by bio-waste and wood. And here are 3 options. We can use a relatively small portion of the total industrial roundwood supply. That was one option. But this is not very cost efficient. Preferred option was use the byproducts from industrial roundwood processing for the chemical sector, for biorefineries. But here the problem is with high competition to the sustainable aviation fuel sector. Or number 3, that would be my favorite, divert a relatively small proportion from the fuel wood sector. That would be the easiest way. So that also means help the regions like Africa, but also perhaps some South America or some in Asia, where they're using the wood mainly for electricity and heat and on cooking. Help them with new technologies that we can utilize the wood biomass in a more efficient way, and also reducing the emissions, because if you use for cooking wood in old systems, a lot of emissions, which can also be substituted by electric cooking from solar, for example. Yeah, I have here a summary slide, and then I have also some additional questions from the workshop before. I go through it because it could be that some of you have the same questions and we have already answered this. So the summary is here. The question is, can woody biomass and agricultural biomass supply this 20%? The answer is yes, it can be done with a moderately high-tech agriculture system. So that means agriculture should not stay like it is or not slowly develop. It should really go a step to a high-tech scenario, a moderate high-tech scenario. That would also be beneficial for the environment, because these high-tech agriculture systems look very well to the health of the soil, health of the crops, of lower use of pesticides. So the pesticide, the fertilizer use could be normally reduced by 20–30% with the same yield. For pesticide, it's clear you have to start very early if insect attacks the field. With fertilizer, it's also easy to understand, because if you know exactly the data of your soil, you can monitor exactly the plant growth. Then you can also be much more better use fertilizer where it's really necessary and not over fertilize other sectors, which finally go to eutrophication to the environment. So high-tech scenario would not only mean additional biomass, it would also mean lower impact to the environment. Providing much more than 20% of the carbon demand would mean to go to stronger high-tech scenarios. If you compare what are the share for Europe from primary biomass and forestry, if we using is for the chemical industry, from the agriculture primary, for the European agriculture primary biomass, the chemical sector would need 8%, and for the European forestry supply, it would be 3%. It also shows again how big the wood supply is, and here very small shares would be enough to feed the biorefineries with woody biomass. Yeah, this is so the final summary, but I will quickly go to the other slides because there was interesting questions and comments, also useful for you. Yeah, the first is very important, especially the wood sector. The report focuses on biomass as feedstock for the chemical derived materials. It does not cover bio-based materials that are not derived from the chemical industry, such as wood in construction, paper or paperboard, which could also replace fossil-based plastics. So that means there are a lot of bio-based materials outside the chemical industry, which can also make sometimes the same services in packaging, for example, and they are not part here. So we only look for processes, for pathways where the chemical industry is included. If you look to chemical dissolving pulp, chemical pulp for fibers, these are chemical processes. This we have included here, but all the standard wood applications are not included here. Derived materials, what does it mean? Also a good question. Polymer plastics and rubber are the most important ones. These are 65%. Polymer plastics and rubber. But we have also solvents, detergents, additives, personal care, pharmaceuticals in the group here. Also, they need, of course, also bio-based carbon for the production. Residues drawn biomass are considered to be used through biorefineries, including biogas, pyrolysis, gasification. So that means we have not included here heat and electricity, but all the different technologies that can be used to utilize residues are included in the modeling here. Wood is used through a wide range of biorefineries, including lignin utilization. So lignin utilization is also mid of the model. Mass balance attribution is fully considered as fossil carbon is replaced by biogenic carbon on feedstock side. Here's one comment. If Europe includes raw material supplies, this can be only done. Yeah, but the question is also in Europe, I think there are countries which could grow additional forest or doing it already. Or in the north, they see also, yeah, you see in the north and also in the Alps, additional forest growing. So that means that the area where trees can grow in Europe due to climate change is increasing. And we see this already today in different countries, north and in the mountains are, that the forest area is getting bigger, climbing up the mountains. So this is also biomass you can use in principle. So it's not so easy to make here a quick conclusion that you can only use converting existing areas. No, the forest is increasing if the temperature is going lower in north and mountain areas. To what degree could logistic constraints impact the conclusion? Yeah, the CAPRI model and the TiMBA model are including trading and storage and other things. So this is included. And you have heard that in this case of straw, we have went from 50 to 1/3 because of logistic reasons. Yeah, if a field is far away from a logistic, it's not very probably that they will also harvest the straw and bring it over a long way to a place where you can utilize the straw. So we have tried to include those constraints, but whether it's fully possible, not easy to say. But in principle, if you use the CAPRI model, the fantastic with CAPRI is is include the real decisions of farmers of the last 40 years. So that means if an area is very low in logistics, and you see also in the model, it's not just used the next day because it's not so easy to use it. So I think some of these things are really included in CAPRI, but you can always improve it. And in our work with CAPRI, we also saw, we have a lot of ideas how to improve it, and there's a long list of wishes. And if you use CAPRI in 10 years, it might be better in those cases, but we try to include it. Yeah. I go to this list here because this question, okay. I think the question is 20%, and Ella is asking how we can go up with 30 or 40%, because L is questioning whether we can really use CO2 in the economic feasible way. I think CO2 utilization has a huge potential and is still very underestimated, just because we will have not only hours and days, we will have weeks and months where renewable energy is almost free of costs. And we see this already happening in Europe, where we're now starting to invest in huge battery parks, which have the size, each size of a coal plant. And the idea is, today we have in Germany in the summertime, we have 3 times more solar electricity as we could utilize. So we're flooding the neighbor countries with solar energy. And the idea is to have battery storage, at least that we can level this in the summertime, that we have not only 5 hours a day, very low prices, but we have 24 hours, a price of 2 cents, 3 cents. And with such electricity costs, you can already today utilize CO2 in a competitive way. And if you see the world data, how we expand solar and wind, it's another presentation. I will give also a workshop on this topic because it's impressive what's happening worldwide. We can expect to have very low price energy soon, and then we can, of course, use CO2 easily. And this is not only in 2050, it comes earlier. And then in Europe especially, we have to mention, due to the regulation, 35% of the kerosene has to be made from CO2 in Europe. And we see big investments here. And as a side stream of the SAF production, via Fischer-Tropsch, for example, we see naphtha. We have estimated 1, 2, 3 million CO2-based naphtha, steam cracker naphtha, best quality, will appear on the markets in the next decades. So that means it's not a question. The chemical industry, of course, will have in the next 10, 20 years naphtha from CO2, and it's a side stream from SAF production, so the price level will also be feasible. So I'm not so pessimistic with the CO2 utilization. We see also in Sweden, for example, that big pulp mills starting now to capture the CO2 and make methanol from it. So it's a very dynamic situation with CO2 utilization. So I'm not so pessimistic. Whether we can go from 20 to 40% with strong high-tech agriculture without harming the environment, this is an open question. Personally, I think we underestimate the options, so perhaps it might be possible to go also higher in biomass production here. On the other hand, recycling, we see that in Europe and in many areas, recycling is number one. There is investment in chemical recycling. So we need this mixture between recycling, biomass, and CO2 utilization. And how the mix will really look like in 2050, nobody knows today. So, we have the scenario 2025, 55, but it can also be that recycling will not work so well. CCU comes cheaper. We have high-tech biomass production. Then perhaps the picture is perhaps 30, 30, 40. Can also happen, yeah. But we will keep an eye on it. And what we did here was based on what you can assume today. But of course, it can happen differently. So I look to this here. And on CCU, I will also write an article soon to show what is going on there. In South Korea, you can have now textiles from CO2. There's so much going on in the CO2 utilization in combination with solar energy. But this is too much for this workshop today. So then was the question here also, not all potential biomass feedstock was considered. Yes, beet pulp, bagasse, algae, agave is not included in the CAPRI modeling. There might be, so that means also here we could have additional, the same as for forest. What is left in the forest is not in the TiMBA model. So it could also be that we take more from the wood without environmental impacts, hopefully. So here's also something still possible in additional biomass. Then the question was about the carbon. Yeah, we have only calculated embedded carbon. That's an important point here. The carbon in the products, in the molecules. We have not the process energy here in the calculation. This is done by energy modeling and by other systems, but this model is looking to the embedded carbon and not to the process. Yeah, this is also, here we have some background information, maintain the soil health, I have also already discussed. And there was a question, why is scaling up starch easier than sugar? And the main reason is that starch is already on such a big scale that a little bit additional for the chemical industry is no issue, but from sugar is comparably small compared to starch. And so the volume of starch production and also the availability of land, of technology, of harvest system, of seeds, make it most easy to scale up starch production. Yeah, I think that was the last slide here, no, the second last slide. Yeah, I have this answered already, also already okay. Yeah, the last question was, can CAPRI model be used free of charge? Because some from participants are very hot to use it. That's the wrong question. CAPRI is so complex that only about 40 experts worldwide can work with the model. The cost is therefore to familiarize yourself with the model and join the CAPRI community. Or invite some of the CAPRI experts to support you. Of course, what is possible, you have some companies are interested now to do that, to have a new set of assumptions, a very detailed assumptions, and then start a new modeling of CAPRI or TiMBA model. That's fine. If you need our support, we love to support you. Especially Olaf has now 1.5 year experience to work with the modeler. In our case, we had really good luck because our modeler was also a farmer, is also a farmer, so he is scientist and farmer. So that was easy to speak with him about all agricultural topics. In the TiMBA model, it was a little bit more academic ones, very useful, but the experience of really people working in the forest was not so fully implemented compared to the agricultural modeling here. Okay, I hit the time, 5 minutes left. Also some participants left. Thank you for your hearing a long time to my talk. If you have some final comments or questions, it's fine. Here is something.
Yeah, so
the forest cover, including plantations, is increasing very slowly, much longer decades. Olaf, can you please show this one slide from the forest presentation where we compare to other reports? I think it would be helpful to have this slide. And it's not only due to the area, it's also due to the varieties. It's due to the, if you have a planted forest, the yield is also much higher than in the natural forest. So this is a combination between, and if you say we're too optimistic, of course it could be that humankind is not stopping deforestation in many countries, and in this case, the numbers will be not coming true. That's right. But we see, for example, Russia and China, that they are very aware of it, and here we see forests growing. So it's also a question on the region. But if Olaf can share the slide, it would be great. I can stop my slide sharing now, because there we have one slide where we compare different reports, and that could help a little bit to. No, it was a statement where there was a meta-analysis.
You mean this one? No.
Perhaps it was in the PDF and not there. Missed. Yeah. Okay. Not easy to. It could be that we have only this in the full documentation. But there was a meta study assessment on 10 reports on wood availability in the world in the last 5 years, and there was a result even a higher additional supply than we have modeled here. So we have compared this to another reports, and it seems to be that we are fully aligned with most of the reports, which really did modeling. If someone did a quick Excel exercise, you can't compare it, but we compared it with some modeling exercises. And so, yeah, but you are right. The assumption is we stop deforestation very soon. We have more planted forest. We have perhaps also some varieties. We have some new areas for trees. Then it could happen like it is, like we showed here. If this all is not happening, of course, we can also have lower supply, but we try to make a transparent system here, what we assumed, and under these assumptions, the results are, I think, in line with many other scientific reports. Okay. Whew. Marco, you want to say something at the end? I talked now 2 hours, it's a lot.
I think we should make a stop here. Thanks, Michael, as usual. You can see from the questions there is a high interest. We will not stop discussing this issue, but we are moving forward. That's the most important.
Yeah, and if you have some questions still also to the modelers, please send an email to Marco, Olaf, or me, and we will send it to the modeler and come back to you with the answer. And if you need some more discussion on this topic in your company, in your association, we are also happy to visit you and discuss only agriculture, only wood, or whatever you would. I think what we would like, because I think it's a very important issue, and we need here ongoing solid data, Marco. And when we see progress in the modeling, we are happy to do it again in 5 years, for example, and also to include climate change in the future. That would be a great challenge for the future modeling. Thank you. Thank you all.